A satellite is in circular orbit around the sun at the height of 2000 kilometers above the Earth's surface. The radius of the Earth is 6371 kilometers. If the satellite completes one orbit in every 2 hours, the speed of the satellite is most nearly. So this radius is 6371 kilometers, and the distance between Earth's surface and this is 2000 kilometers. Right, and the time period is equal to 2 hours. The speed we have to find.
Yeah.
T is equal to 2 pi upon omega, or I can write it as 2 pi r upon v. So omega is
Yeah.
equal to v upon r. Just find omega first and then we can change it. We can find the velocity. So
Okay.
what is omega in this case? It would be 2 pi upon 2r. So it would be pi upon pi radian upon hour. This is omega, and what is omega is equal to velocity upon radius. So I can write pi radian upon hour. So the answer is asked in second. So what I can do, 1 hour is equal to 3600 seconds. I can write it as, okay, 1 hour as, so it would be pi upon 3600 radian per second. So it would be equal to velocity upon radius. And what is the radius? What is r in this case for the circular path? So from the Earth center to the satellite, what is the distance? So it is 6371 kilometers plus 2000, because from the Earth's surface the satellite is at 2000 kilometers. So
Yeah.
it would be 8371 kilometers, the total r.
Yeah.
So here I can write 8371 kilometers. So velocity would be equal to 8371 into pi divided by 3600 kilometers per second. This would be the unit.
7.3.
7.3 kilometer per second. So this is the velocity. D is the correct option.